Hi everyone, in this video we're going to talk about the horizontal line test. So notice I already have two graphs pre-written out for this section. One of it's of x squared and one of it is of x cubed. And last video we talked about one-to-one functions, and we said that x squared is not one-to-one and x cubed is one-to-one. So now we want to use these to help guide our intuition for a test, which we're going to call the horizontal line test, that detects this behavior of one-to-oneness. So let me change my color here real fast. So one of the things we noticed last time was we said that this point here is 2, 4, and this point here is negative 2, 4. And because the y-coordinate was the same, then this graph had to not be one-to-one. Because that violated our definition. But also notice that since they have the same y-coordinate, they actually lie on the same horizontal line, y equals 4. And notice that any horizontal line above or on the x-axis will intersect this graph. So we can go to this point right here, which will give me the line y equals 7, and it will intersect the graph twice, here and here, at 7 root 7 and negative 7. Or no, that's not, sorry. Try again. Root 7 comma 7 and negative root 7 comma 7. Backwards. So, but notice over here we have this point here, which is 4. So it will go intersect the graph just once here at the point cube root of 4 comma 4. I pick a line down here and notice that it intersects just at once, and in fact I could pick any horizontal line and it will intersect the graph of x cubed just once. And so that's the idea from the graphical point of view of one-to-oneness. This is not one-to-one because we can find a horizontal line that intersects in 2 points or more. It doesn't have to be necessarily 2. It could be more than 2 points. But here, this is one-to-one. And so notice I'm using my abbreviation from the end of the last video because we always exactly intersect one time. Now, intersections of 0 is allowed, but so an example of that, since I said it, is this. Is the square root function is 1-to-1. So let's draw it carefully. So we have 0, 0, 1, 1, 4, 2, 5, 6, 7, 8, 9, 3. So here's the square root function. And notice if we let any horizontal line, so down here there is no crossing, and that's okay, 0 crossing. But starting on the x-axis we will get, and that was a crappy line, let's try again. So on the x-axis we'll get a point here. On the line y equals 1 we'll get this point. On the line y equals 2 we'll get this point. Y equals 3 we'll get this point. They don't have to be integer values. You can pick one that's not integer, and it hits exactly 1 point. So this function, f of x equals the square root of x, is 1-to-1 as well. So 0 crossings is allowed. So our definition then becomes this. Our test becomes this, rather, not a definition, is that a function is 1-to-1 if every horizontal line intersects the graph at most once. So we hit more than once here. So it is not 1 to 1. We always hit once here. So we're 1 to 1. We hit 0 times in this region, but once we get up here, we always hit once, which is 1 to 1. One thing I do want to be careful of, especially a lot of you will have the tendency of want to just graph it, and you have to be careful when determining 1 to 1 from a graph, especially with using technology. And this example I pulled up in Wolfram Alpha is a perfect example. Here I asked the computer to plot x cubed minus 6x plus 4 plus 12. And notice that in this graph, where our range was from negative 2 to 6, and our domain was from negative 2 to 6, and our range was from negative 30 to 40, we can see that it is definitely 1 to 1. I put well, you can't see it, and I can't draw on this, but you put in any vertical line. Oh, here, again, kind of any vertical line, and this actually intersects at 3 points, so this is not 1 to 1. But if you change your scale, and look, it looks like it's 1 to 1. So you have to be careful about scale, because when you zoom out, little permutations like this smooth out and look straight, even though they're actually not straight around here. It's just on the scale, it kind of looks like it. Just like how you don't, even though something feels smooth, there's usually some sort of little bumps, or some sort of roughness to it, you just can't feel, because your sensory system isn't designed to feel something that has that fine of can't detect whether there's roughness there or not. It just feels smooth. So that's the same idea. It's just you can't detect the roughness there because you're so zoomed far out. So, just a word of caution with technology, just be careful. Make sure you've zoomed in or out sufficiently enough so you can see whether you have little ups and downs like this. So that's the horizontal line test, and the next thing we'll talk about are inverses. See you then.